Okay, ladies and gentlemen, it is 3:15, and we should get this underway. If I could have your attention. We are going to need to set up a new interactive job in a different queue now in order to use the TensorFlow system. So if you are still in your interactive job, you're going to want to exit that and get back to the shell on your login node, which will be something like BR012 or BR014, rather than one of the R something nodes. Just keep exiting until you get to there, basically. And once you've done that, you don't need to do the CP commands and all of that anymore since we've already done that. If you weren't here for the other part for some reason, though, you will need to do the CP, the training, big data stuff. Anyway, from the login node on Bridges 2, you're going to want to run this command here with this reservation. This is a different reservation that uses the GPU nodes. Go ahead and get yourself set up there. I just realized that I don't have the command there that you're going to need to run. I think I have it in the file that's on the Moodle, but not in this one. This is in a terminal, so This will be the command. I'm going to just paste this into that other one. Oh, here it is. Okay, good. Okay, so once anyone having any trouble getting the interact started? Okay, I'm going to assume that that's going swimmingly. Raise your hand if you have a problem with that. Once you're in that session, you're going to run this. You can use tab completion to make typing this a little less hassleful, or you can go and find the command on the Moodle in those startup commands to do the singularity shell --nv, ocean containers, ngc, TensorFlow, and then this particular TensorFlow image. Okay. We're going to want to get into the mnist directory so that we have access to our files. And then we're going to go ahead and run, just so that you can see what happens, we're going to run a TensorFlow program. We're going to run cnn dropout.py. This is basically the culmination of what I talked about this morning. All of the steps that we required to get to doing a convolutional neural network with dropouts to do a very high precision, over 99%, learning on character recognition. Okay. I'm going to come back to these commands in a second, but this should take a few minutes to run, and it's going to run through 15 epochs, and you're going to see the validation accuracy and the training accuracy, and you're going to remember that the validation accuracy is the one that we really want to see maximized, and if we find that the validation accuracy is lagging behind, that might mean we're overtraining, and if it is getting real close, then we're doing a good job. So, all right. Okay, well, I can tell you a little bit about it while I'm waiting for my computer to become responsive here. What we're going to be doing is taking these images of clothing that are also 28 by 28 grayscale images, just like the character recognition ones, but the problem set is a little bit, and there's also exactly 10 categories, so in a lot of ways it's a perfect drop-in. In fact, it's literally a perfect drop-in. We just have to change one line in the file, and we'll have a pretty good attempt at doing this. So, let me see here. Okay. So there's 60,000 training images and 10,000 test images. And the exercise is just to tweak the hyperparameters and try to do better than the baseline. So did everyone run that character recognition CNN dropout without problems and see the output come down? It showed you the output for the 15 epochs. Just raise your hand if the answer is yes. Okay, good. It looks like we got some people who got it, and that's good. So, let let me one more time go back to, well, actually, I think we have this in the next slide, don't we? Yes, okay. So there is a line, I think it's like the third or fourth line in the file in that CNN dropout file. What I encourage you to do is make a copy of that file, just CP it to like fashion.py or something like that, and change this line from tf.keras.datasets.mnist to tf.keras.datasets.fashionmnist, and then save it. You can run it the exact same way that you ran the previous one. Incidentally, if you're in the container, you won't have Emacs. If you're used to Emacs, you have to use VI or something. Or you could edit it outside of that if you wanted, and it would work too. But anyway, go ahead and do that and run it. And I think what you're going to see, you're going to run up with about, let's see, I think it's going to come up to about 84%. That's the other one. Oh no. Okay, no. Okay, we'll get about 92%. I'm sorry. So, take a look inside the file, play with the number and type of the number of neurons, the number of layers, and let me also, if you've read the slide here, you'll see the last paragraph, and this is very important. This is there is no such thing anymore as a closed book test. This is not only an open book test, it's an open internet test, open person test, open world test. So use every resource you can imagine to try to find strategies that might help you to pump that validation accuracy up a little bit higher. So let's see. We have until about 4:20, and then I'll review some solutions. Okay. We have questions? Oh, this is the fashion database here. Yeah, so we got to 99% accuracy with the character one, and using the default settings are the same as we use for the character. We're going to get about 93% accuracy on the clothing database. So start trying things. Do you mean? So the answer is no. There's two layers that we have to get into here to make this work. The first one is the interact with the dash GPU argument, and that gets you on a node that actually has a GPU and gives you one of them. And the second one is you have to be inside of the TensorFlow image. Oh yes, in fact, I mean you should. So the command here, I don't know if you'll be able to read this. Yeah, so I called my file fashion.py. You can call it whatever you like, but that's just run Python space fashion.py. There probably is a way to do that, and I haven't done it in so long. I'd have to look it up. So if you'd like, you could try to figure that out. But this definitely works. I would stick with this for now. Remember that if you want to do anything else, you could always open a second terminal and connect to the login node if you want to do things like editing files or whatever. I'm sorry, it's very hard to hear. No, you just have to just load this this singularity image. Okay, let me come and see. Okay, it is 4:20 now, which is a little later than I had originally planned to bring us to a close, and I do want to make sure we don't have to rush to the bus. Anyone want to share? Did anyone get a very high accuracy count on the validation numbers? Who has a validation number to share that they're excited about? The baseline is 0.9274. Did anyone? Let's start here. Did anyone beat that? Yeah. By 1% is a lot. What was your final number? Do you have it there? Okay. I mean, that's definitely an improvement. It's a step in the right direction. Okay, well, I mean, I hope that you had a little experience in seeing that poking around can make changes sometimes for the worse, sometimes for the better, and to really make significant improvements is going to take a little bit more effort probably than just random changes, but you never know. I mean, apparently the dropout thing was kind of found by accident, and sometimes you can just finagle a slightly better result, but we had already done quite a bit of work to get to that 93% number. So I'm going to skip through these, but there is some information, and these are in the slides, about if you want to add TensorBoard to do the viewing of your the graphical output and stuff, and makes it kind of nice and easier to look at. Okay, Some of the networks are, if you do a little bit of a web search, you can find that some of them are getting like 96%, and some of them are really big networks, and you can follow through to these to see how some of them did it. There's the KMNIST one that is doing a very good job with it, and the AlexNet one, which we talked about earlier, it was getting somewhere around 94% on the clothing database, and that's as you found, changing it around to get that much is quite a bit. So this is a bit of a tricky problem, and we don't have a clear number for what's superhuman on it. But here's an approach that got over 94% of this set of hyperparameters. And let's see, what was it in this one? Sorry, this was changing the gradient descent in order to speed that one up. And you can look at all these hyperparameters. Like I said, we're going to go pretty quickly through this here. But making some of these changes will allow you to get some better performance. Here we go with a 2-step forward and 1-step back attack. We got up to 93.7, and that was the best that we got when we were working on it back in Pittsburgh. So going from 92 to 93% is a big step, and getting even more is, if you can do that, then you're making big progress. So in any case, I hope that you found that this was useful practical experience for working with TensorFlow and for being able to start attacking different kinds of problems with it. And I'm happy to converse with you beyond this, but at this point, first, does anyone have any questions? I guess we should go there. Okay, well, let's go climb a mountain and have some dinner. Okay, thanks everybody.